This is the video for special cases for systems of equations, and we're going to start by putting together the foldable. The first thing I did was just fold it in half, and then I'm going to open it back up, and I'm going to cut along these solid lines separating these graphs. If you cut along these dashed lines, you're going to cut it incorrectly, so cut along the solid lines on the inside. I'm just going to take my scissors. And then if having this part on the bottom really bothers you, you can cut the solid line all the way across. Now we have a little flip book. So now that our foldable is ready, we can start with the one solution. We're going to start off first with using a graph. So the first thing I need to do is convert these two equations to slope-intercept form. So I have x minus 3y equals negative 9, and I have x minus y equals negative 1. I'm going to start with this one. I'm going to subtract x from both sides and get negative 3y equals negative x minus 9. And then I'm going to divide both sides by negative 3 and get y equals positive 1/3 x plus 3. Negative x divided by negative 3 is a positive 1/3 x, and negative 9 divided by negative 3 is positive 3. And this next one, I'm going to add y to both sides, get x equals y minus 1, add 1 to both sides, and I get y equals x plus 1. So now I can graph these. If I start with this one, I have a net y-intercept of 1 and a slope of up 1 over 1, up 1 over 1. And then if I connect those dots, I'm going to use a CD case here. I can then plot the other equation. I've got a y-intercept of 3 and then a slope of up 1. Oh wait, not that. I have a y-intercept of 3. Sorry, I originally plotted it at 4. Up 1 over 3, up 1 over 3. And now I connect those dots. So with our two lines here, we see that they intersect at the point 3, 4. That is exactly one solution. If we were to check this and plugged in 3, 4 to either one of these equations, they would be a true statement. Our only answer is at 3, 4. Again, this is the one solution type of special case. We can do that again using substitution or elimination on this problem. I'm going to start by using elimination because I have a 2x here and a 6x here. So I feel like if I can multiply this top equation by negative 3 on both sides, I'll be able to eliminate the x term. So let's take 2x plus 5y equals 14. We're going to multiply both sides by negative 3. And we'll distribute that negative 3 to both terms and get negative 6x minus 15y equals negative 42. Sorry, not 32, 42. I can now add the second equation to this one, 6x plus 7y equals 10. When I add those together, I get negative 6 plus positive 6 is 0. Negative 15y plus positive 7y is negative 8y. And negative 42 plus positive 10 is negative 32. If I divide both sides by negative 8, I end up with y equals positive 4. I can now plug that y equals positive 4 back into either one of these equations. So let's start with the second one. 6x plus 7 times 4 equals 10. 6x plus 28 equals 10. Subtract 28 from both sides. 6x equals negative 18. Divide both sides by 6. X equals negative 3. So the solution for this system of equations is negative 3, 4. And again, we have exactly one solution. So now let's try this again for the no solution special case. So let's start off with graphing. I'm going to convert both of these equations again into slope-intercept form. X minus y equals negative 4. I'm going to subtract x from both sides. I get negative y equals negative x minus 4. I can multiply both sides then by negative 1. And I get positive y equals positive x plus 4. My second equation, negative 3x plus 3y equals negative 6. I add 3x to both sides. I get 3y equals 3x minus 6. Divide both sides by 3. Y equals x minus 2. Now I can plot both of these. My first one has a y-intercept of 4 and a slope of 1, so I go up 1 over 1, up 1 over 1. I connect my dots and draw my line. My second equation has a y-intercept of negative 2 and a slope of 1. So I go up 1 over 1, up 1 over 1, and I can connect my dots again. You can see on this that they are parallel lines. My line's a little off, I apologize. There we go. That's the right line. So, the lines are parallel, they will never intersect, and so therefore we have no solution. So let's try it again using substitution or elimination. So right here I've got x minus 2y equals 7 and negative x plus 2y equals 7. Well, let's try using elimination. If we go ahead and add these equations together, x plus negative x is 0. Negative 2y plus positive 2y is 0. And 7 plus 7 is 14. We end up with 0 equals 14. 0 does not equal 14. So again, we have no solution. So when you are not using the graph method and you end up using substitution or elimination, and when you do this you end up losing both of your terms and getting number does not equal a number, that's a good sign that you have an answer of no solution. The last special case is infinitely many solutions. So again, we're going to start by graphing. We will convert both of these equations into slope-intercept form. This is a negative 1. I have x plus 3y equals negative 1 and negative 2x minus 6y equals 2. I'm going to subtract x from both sides. I get 3y equals negative x minus 1. Divide both sides by 3. And I get y equals negative 1/3 x minus 1. Oh, minus 1/3. Negative 1 divided by 3 is negative 1/3. On this one, I'm going to add 2x to both sides. I get negative 6y equals 2x plus 2. Divide both sides by negative 6. I get y equals 2 divided by negative 6 is negative 1/3. X plus 2 divided by negative 6 is again negative 1/3. They're the exact same line. So now if I were to graph both of them, they'd be at the exact same place. I go to negative 1/3. I'm going to say that's about there. And then my slope is down 1 over 3. Down 1 over 3. So if I connect my dots, if I were to graph the other equation, it'd be right on top of it. Because they are the exact same line, I have an infinite number of solutions. Any point on that line will make the system of equations work. Let's see how this looks when using substitution or elimination. Because my second equation here already says y equals 8x minus 1, I'm going to use substitution on this one. So I'm going to substitute this into my first equation. Negative 16x plus 2 times 8x minus 1 equals negative 2. Negative 16x plus, I got to distribute my 2, I get plus 18x minus 2 equals negative 2. Oh, sorry, 2 times 8 is 16, not 18. Negative 16x plus 16x is 0, so when I combine like terms, I get 0 minus 2 equals negative 2, which reduces to negative 2 equals negative 2. And this, my friends, is an identity. So here we have an identity, which means that we have infinitely many solutions. And there you have the three cases. You will either end up with one exact solution, no solutions, or infinitely many solutions, meaning they are the same line. So the big thing you need to remember is that when it is no solution, the lines are parallel. When it is infinitely many solutions, they are the exact same line. See you in class on Monday.